Okay, so the goals of today's workshop, what I'm hoping to fit in, is to give you a quick overview of how to download the data, your group's data, or any slice of the data that we have available now in the National Phenology database that we maintain, which is really huge thanks to groups such as yours. We have over 5 million phenology records now that you can access and do things with. And then I will guide you through several different types of questions that we can explore. Some basic summary statistics, which are things like how many records have members of my group submitted, how do we do this year compared to last year, how many different unique dates have we observed data on, that kind of thing. A little bit on participant retention, because that can be a sticky kind of thing to estimate or evaluate, but a very valuable metric if you're a program manager, and especially if you need to argue for additional funding going from year to year. A little bit on observer accuracy. We've definitely gotten the question of, how can we easily or readily compare the observations that our volunteers are making to our experts? Usually it's the leader. Can we directly compare that and see and identify which volunteers might be submitting data that look like outliers, maybe kind of questionable in nature? And then finally, phenological patterns. And I'm so excited to reveal to you that on that front, we can just refer to an online tool, our new data visualization tool that's going to be going online in a handful of weeks now. So I'll give you a quick demonstration, just a really quick peek into some of the kind of stuff that you'll be able to do with that. And that's going to be so wonderful because it means that you'll be able to play with all the data online through the tool and not have to download it and do fancy things on your own. So to start with downloading the data, there are a couple of different options. One of the things that we can do, I did send out a handout just about 45 minutes before the webinar started. Some of you might have received it. If you did not, you can check your inbox after the webinar or whenever. But it's a really handy handout because it does walk you through how to download data in a couple of different ways. And then it walks you through one example of creating a pivot table in Excel. And the main reason that I wanted to share that with you is that we're going to spend a lot of time using pivot tables today. It's kind of the key to summarizing data really rapidly in Excel. And even though the handout only demonstrates one way of how to do that, once you play around with it and get the hang of it, and I'll be demonstrating about 5 different ways of doing that, you will see that that tool offers you a great amount of power for getting answers. So to get at your data that your group members have submitted, there are a couple of different ways. One is by using what we call our data download tool. So if you go to the USA-NPN homepage and under the Get Data menu, there is this Download Phenology Data link. This will take you to what we call the data download tool. And there are a couple of different formats that you can download the data now in. There's something called raw data, and there's something called summarized data. There's a good description of the difference of the two of them on this web page, which you can refer to later. But in a nutshell, basically, raw data provides to you every single observation record as a separate row in the file. And what we mean by record is anytime you go out to an individual organism, a plant or an animal, you are faced with a series of yes-no questions. And sometimes it's as few as 3, and sometimes it is as many as 10. But for example, if I were going to make an observation on my desert willow in my backyard today, I would be faced with, do you see breaking leaf buds? Yes or no. Do you see leaves? Yes or no. Do you see flowers or flower buds? Yes or no. Each one of those yes or no questions comprises a single record in the database. And if you download the raw data, you get all of those records as separate rows, which is important for things like generating summary statistics about your observers' participation over the course of the year. However, it's not all that helpful if what you're really interested in pinpointing is, for example, when did I last report no to open flowers on my desert willow this year, and when did I first report yes? Because that pinpoints in time when did that transition occur, And when we're actually analyzing the phenology data to see if if the timing of these events or these transitions are changing through time, that's kind of the metric of interest. And so if that's the kind of question that you have, then the summarized data is the more appropriate thing for you to focus on. What the summarized data will yield for you is for a particular individual plant or animal in a given year, what was that date of transition? When was the last no for a particular phenophase reported? And then when was the first yes reported, so that you can easily focus in on that transition time. And then it enables you, if you have observations on that same individual over multiple years, it enables you to really rapidly compare across those years and see what was one year dramatically earlier or later than the other, or do we have a pretty consistent timing of shift or of transition. So in this case, we would focus on the raw data if we were trying to get all the data for our organization for the kinds of stuff that I intend to summarize today. And the one thing that I want to point out to you is that if you are interested in summarizing data for your group and you're at all interested in tracking the contributions by your different individuals, your different volunteers, then you definitely want to make sure that you check this optional field called Observed by Person ID. What that's going to yield for you is that it's going to attach to each record the internal ID that we assign, which is a numeric code that's unique to every single Nature's Notebook participant. What this won't tell you is who the person is. It's still a magic number of like 72 or 4096 or something like that. But it will allow you to track, it will allow you to summarize how many records came from different individuals in your organization. Now, if you are actually interested in knowing who submitted the data, then you should actually download the data from within your observation deck. And how you would do that is, and this part is described, actually I think both of these ways of accessing the data are described in the handout that I emailed you before the webinar. So don't stress if you're not quite getting every single one of these details. So you would log into my observation deck, and then for a group that for which you have, you are an admin, and for me, I am an admin of this one that actually has no data in it. You select that group, or I'm sorry, that site, and then you would go to Edit Site, and then this orange link right here, the Download Site Data, will download the data that's been submitted for that site, and it would actually attach user email addresses to it, so you would know which records were coming from which individuals. And it again yields the data in the raw format. I'm not actually going to do that now because this file is empty. There's no data associated with this site. So if I downloaded it now, it wouldn't really show you anything. So those are the two primary ways of downloading data. And so the next thing that we're going to do now is move on to some of the summary statistics. But before I go on, are there any questions specific to the downloading data? Oh, can you guys see my screen? Someone asked if she should be able to see it. Yes, you should. Are all of you not seeing my screen? Can anybody see my screen? Okay.
Yep, some people can see it.
All right. Yes, okay. I think we're in good shape. Okay.
And we did have one more response to your first question that came in a little bit later from Hallie at Mohonk Preserve. And she said that she's hoping to learn how to look at volunteer data on an ongoing basis so they can target common problems in trainings and provide individual feedback.
Perfect. Okay, we should be able to get at that. That's a little further down the line. Crystal, if you're still having trouble, you might want to try logging out and logging back onto the meeting using the same link. I know I've had that struggle when I've been calling in from home. I think it sounds like it's working for just about everybody else. I apologize for that. Okay, so first, in terms of summary statistics, the kinds of things that I thought we could cover today are questions along the lines of how many records have my individual volunteers submitted in each year of my program? So if you're interested in just seeing if you have really good, consistent participation, or if you've got, you probably would know if you have a super volunteer or maybe a few that are not so committed. Next, we'll look at how does my group's observation activity this year stack up to previous years, and we can easily address that from an annual basis or from a monthly basis, and I'll show you how to do that. And then third, I thought the question of how many dates did each of my participants take observations. So what I'm going to do now is open up the Excel file that I sent to you, and if you want to open it up and look at it on your end, you are welcome to do so. Otherwise, you're welcome to just follow along here. I'm going to shrink this for now. And the first thing I'll do is walk you through what this raw data file is. This is what, if you download the raw data from either the data download tool or from your observation deck, it looks pretty similar. And I'll just walk you through what we're looking at here and then kind of orient you to what we care about and what we don't care about. What I did for this file was download all the data that had been submitted by members of a group that we have locally called the Tucson Phenology Trail. And so it's actually a really enormous file, and we'll be working with subsets of it, but I wanted to have more data than less so that you could see kind of some different situations. So the very first thing, and I downloaded this from the data download tool, the first way that I showed you, rather than from within my observation deck. And what I did make sure to do was check that observation observed by person ID. And so that's what that's what this very second column is. The very first column is a unique record, or I'm sorry, a unique code that's assigned to every single observation. We're not really going to pay attention to that this time. The second column, though, is actually of value to us. This is the code that's assigned to each observer. And so you can see that there are many records in this first batch that were submitted by the person with the ID of number 5. And I happen to know that that's Jake Welter. And then we have a few records that we can also see by whoever is 1190. And if we page down, we'll see there are many, many other observer IDs too. The next few things I'll walk you through quickly, and then we're going to ignore a lot of these today. This is, if you were to go in and update the status of a record, this would tell you, this update date time tells you when that record was updated. None of these records have been updated, which is why they have a -9999. If you have a partner group, then that shows up here. And so you'll see we have many different partner groups associated with the TPT. U of A Campus Arboretum is what we're seeing up at the top. The site ID is the code assigned internally to a site. Latitude and longitude, elevation, all pretty self-explanatory, as well as state. The species ID is the internal code that we assign to the different species. And then you've got your genus, species, and common name. The individual ID is the code assigned to an individual plant or animal. So in this case, we're looking at records for all the same individual, all the same individual creosote bush at this point. The phenophase ID and phenophase description have to do with what phenophase we're talking about, whether it's breaking leaf buds or ripe fruit. The next field is the date on which the observation was taken. The very next field is the day of year, which is the we automatically for you. What that refers to is January 1st is day number 1, January 2nd is day number 2, and then all the way through the year, the order of days is counted in a consecutive fashion all the way up to December 31st being either day 365 or 366 in the case of a leap year. And we go ahead and auto-calculate that and provide that to you because it's pretty handy when you're trying to do something like run a regression. So if you wanted to see, for example, if the beginning of like the onset of open flowers for a particular species was becoming earlier over the course of time, then you might regress that day, first day that it was seen in day of year versus year. And so that's why that's there. Finally, we've got phenophase status. And what that refers to is the yes or the no, whatever was reported there. If it was a yes, it's a 1. If it was a no, it's a 0. And if it was question mark, then it's a -1. So what I usually like to do is go in and clean things up just a little bit because this is a big bulky table. And so right off the bat, I tend to delete fields that are redundant. And so like in this case, we've got species ID, genus, species, and common name. I'm just going to stick with common name and get rid of everything else. I already know everything's in Arizona. So I'm going to get rid of the lat long, the site ID, all that kind of stuff, because I don't need all those. I'm not going to worry about when it was updated. That's not of concern to me. And I'm going to get rid of this observation ID just to trim it a little cleaner to work with. Then the very next thing I'm going to do is we care a lot about in today, what we're going to do today, about summarizing records based on either the year or the month. And we don't have those as unique data fields right now, but we do have this wonderful date field. So one thing we can do pretty neatly in Excel is just auto-calculate that. So we can create a column called year, and then using a built-in function in Excel called the year function, you type equals year, and then just reference that date field, and then it will auto-generate the year for you. We can do the same thing to calculate the month, or to extract the month from the date field by using an auto calculate function in Excel that's called month. So you type equals month, and again, reference that date field, which is just a few columns to the left, and hit return, and it'll auto-calculate it for you. And then, since we have a huge amount of rows and we don't really want to have to drag this all the way down, another neat thing about Excel is that if you highlight both of these fields and then put your cursor over the lower right corner, it turns to a plus, a little plus. And if you just double click that, it will auto-fill everything all the way down for you. Then, one more thing that I tend to like to do is to take data that are formulas and turn them into actual values, because sometimes when you're referencing a formula later on, things can get wonky, and we don't actually need to retain these formulas anymore. The important thing here is that we know what the year is and that we know what the month is. What I mean by that is when I hover my cursor over one of these cells, the content of the cell looks like it is the year, but if we go up here into the formula bar, we see that it's actually still a formula that's being calculated. And so a way to convert that to the actual value for the year, which is what we really want, is to copy, highlight both of those columns, then right-click and hit copy, and then right-click again and hit paste. But instead of just doing a regular paste, you're going to want to do a paste special with the values. And so what that does now, if we now go to any of the cells and look at the content of them, we now see we no longer have that formula anymore. It's actually a value. And so we can't go backwards anymore. We don't have that formula. We've overwritten it. It's just the value for the year or the month now. But since we're going to be using these data as these data going forward, that's okay. Okay, so what the heck was our question again? What we're trying to summarize here is, the very first question we're trying to answer is, how many records have my individual volunteers submitted in each year of my program? Okay, so for that question, we're trying to summarize, we're trying to total up the number of records by person, by year. And so there's a really, like I said, using pivot tables, this is actually a really pretty quick thing to do. And so if you haven't used pivot tables before, then you're going to be excited, because this just opens up a whole world of cool stuff we can do. Basically, what we need to do is, the thing I like to do because it's just easiest, is select the data for the whole spreadsheet by clicking that upper left corner of the spreadsheet. And then we are going to go into the data tab. No, I'm sorry, insert. It's the data tab if you're using a Mac. I should actually ask, if anybody's using a Mac, can you just type in the chat box and let us know so that I can make sure that I tell you where to look on a Mac? If you're using a PC, you go to the Insert tab, and you're looking for this button right here called Pivot Table. You just click on that, and then, okay, we have someone on a Mac. Good to know. I'm pretty positive that the Pivot Table function is nested under the Data tab on a Mac, so let me know if that's wrong. The interface it'll bring up will prompt you for which parts of the spreadsheet we want to pay attention to, and since we already grabbed the whole thing, it's defaulting to that, and we're going to just say, yep, that's fine. Then it's going to ask us, where do you want to put this pivot table, and we're just going to go with the default of a new worksheet. We say, okay, And so you'll see that it opened up a new tab on our spreadsheet here. And what we are going to do is we have this really neat interface here on the right where now all of the fields from our table are listed, and then we can drag them down into these different boxes down here where those tables can either serve as the rows for how we're summarizing it, or the columns, or the actual values, which means the content of the matrix. We're going to be building a matrix now from our tabular data in the previous spreadsheet. And so for this particular question, again, we're interested in data summarized by person by year. Then what makes the most intuitive sense to me is to take the observed by person ID, again, that's our code referencing our individual people, drag that down into the rows, and then you'll see these are each of our observers' IDs. Remember, we've got number 5 is Jake over there. And then we want year as the column. So we drag year over here. And so now it's going to total our data by person by year. And the last thing that we need to do is just grab, actually, in this case, any of the other fields and drag it into the values field. The reason why it doesn't really matter what I drag down there is because we're basically just asking Excel at this point, count up the number of records. Just count them. Don't worry about what the data are in the records. Just count up how many records there are by person by year. And so I'm just going to grab, for fun, phenophase status, pull that into here. And notice that if I click on that, it defaults to count. And that's a good thing, because that's what we wanted to do, is count up the number of records. And that's mostly what we're going to be doing today. But if we clicked on this value field setting, you could actually change it to min, max, sum, product. And you would invoke those if you were actually saying something like, if the data in your cells were something that you wanted to sum, for example, instead of just count. In this case, we care about how many records, which is just simply a count. And so what we have now is our answer. We have the number of records submitted by Jake in 2011 as part of the Tucson Phenology Trail. He submitted 820 records. In 2012, he submitted 391. In 2013, he didn't do anything. I will assume he collected data elsewhere. In 2014, he submitted 76 records, and nothing has been submitted as of the date when I downloaded this file. Another nice thing is that it auto-calculates totals for you too on the right. And then also, if we scroll all the way to the bottom, you'll see we have totals for the years as well. And so what we can do then is, if we're interested in working with this even further, the thing I like to do is actually copy and paste the content from pivot tables rather than trying to make graphs, for example, right from a pivot table, because they get very messy. It's, again, kind of the same thing as overwriting your formula with the actual value. So what I like to do, and I'm just going to grab a portion of this table because it's so big it's almost too difficult to work with. And I'm going to grab a portion of this, just a small portion, and copy. And I'm going to create a new worksheet and paste it into here. I'm going to paste the values. If I did a regular paste, I think I can't remember if that results in a pivot table or not. I usually go with values just to be sure that we're not carrying over any of those formulas anymore. Again, we just stick with the summarized data here. And so we can change this to observer. And then we've got our years across here. And then if we wanted to say, see how much data were submitted by person by year, we might grab that and just build a graph from it. In a PC, you just go to the Insert menu and choose a graph. I like to do stacked graphs because then they don't get too bulky, but you could always do the clustered columns or anything else that you like. And then if we wanted to add the observer IDs, you can right-click in here and hit Select Data. And then for the horizontal category access labels, that's our observer ID. We go grab those over here. Probably many of you know this better than I do. And then I always have trouble with the legend series names not appearing in the graph, which is why I did not grab them when I made these. There's probably some trick that you know that I don't, but I just go in and manually change them to what they should be by clicking each one and clicking edit. And so I'll just clean this up real quick so that we know what we're looking at. And there we go. Say okay. And there now we can see how many records. Let's see, we'll title it. How about? Be very explicit. And what this enables us to do then is look really quickly across our different observers and see how much data they submitted in each year. Let's see. Oh, and one other thing that I thought I would mention for this too is that, well, maybe I'll stop there. Are there any questions specific to anything that I've done so far? Okay, well, one other thing I thought I'd mention while we're here is that after you've summarized things in the pivot table like this, it's pretty simple to go just one step further if you're interested to calculate things like averages or standard deviations, which I had someone ask over email. So for example, if we were interested in knowing not only how many records different observers submitted in each year, but also what the mean and standard deviation of those are, so that you could really see, like, did one year jump out dramatically from the others, then you, again, can do that using Excel's auto calculate functions pretty readily. So we can just do that down here pretty quickly if we wanted to do the average or mean, which is the same thing. Number of records submitted, you can go at equals AVG is the function in Excel, and then grab this column. And the nice thing is it's smart enough that it will treat blank cells as no data. If you had zeros in there, then it would count them, and that would throw your average off. And so it's a good thing that we have them blank in this case. And then if you're interested in seeing the standard deviation, again, this is a pretty straightforward one in Excel. It's STDEV, calculate standard deviation. And then grab that same portion of your matrix, and then there you go. And then if you wanted to drag this across for all of the years, you just, again, like we did before, highlight both, put your cursor over the lower right corner so it's a plus, and drag it across. And then there we go. So what we see is that in 2012, we definitely did better across, on average, the observers submitted more records than in any of the other years. However, we also had the greatest variation in that year, and so you have to interpret that for what it is. Okay. If there aren't any additional questions, then what I'm going to do is something that I always like to do, which is label the tabs on my spreadsheet and then keep them and then clean up as I go, meaning deleting some of the working spreadsheets. So in this case, I'm going to go ahead and rename this one. Let's see, it's records by observer year. And then you'll notice when we go back to this sheet one, that's the spreadsheet, or that's the sheet that was created by the pivot table. And since that was kind of an intermediate step, I'm just going to delete it by right-clicking on the tab and hitting the delete. And it'll warn me, and I'll say, it's okay, it's okay. And then we'll save it, because we never know what can happen. And then that answers our first question. So if we go back to our list of questions, the next one is, how does my group's observation activity this year stack up to previous years? And in this case, we could ask that question by year or by month. So for example, was our activity greater in this March compared to last March, or how do they stand up? And so in this case, it's not so different than what we just did in the previous example, but instead of summarizing things by observer by year, we're trying to do it by month and year. And then we can graph that pretty readily too. So what I'm going to do for this one, it's, like I said, again, it's fairly similar to the one we just did, but we'll walk through it to kind of reinforce the concepts and see a slightly different spin on how we do this. again, we go back to the original spreadsheet that I have. So I'm back at the place where we began, and we're just going to work from that spreadsheet. So if you got lost in the last one, we're starting from scratch with this new one, and you can try and follow along again. What I'm going to do is just click in the upper left corner and highlight the whole spreadsheet, because again, it's just handy to have it all. Alternatively, since we only care about month and year, you could just highlight the month and the year columns for this one. We go to the data, or I'm sorry, data if you're on a Mac, insert if you're on a PC, insert, pivot table. Again, we'll just go with the defaults here, say OK, and it brings me again to that pivot table interface. And we're going to drag month down to the rows and year to the columns. You could do it either way. It doesn't matter at all. I went with it this way because there are more months than there are years in this particular data table, and I find it easier to have the longer one on in the rows, but it does not matter at all. And then again, it doesn't matter really which field we pull down into the values, because again, all we're asking Excel to do is count the number of records. Don't pay any attention to the data that are in the records at this point. So either one of these or any of the other fields would be fine to drag in here as long as we're saying count it. And so again, what it did, what the totals are here now that comprise our matrix is simply a count of records that were submitted by anybody now in this particular group by month and by year. And so once again, we can copy this. Maybe I'll just grab just the data, create a new sheet, right-click to paste values, and there we go. And in this case, I'm going to retitle this month in case I get confused. And then it's pretty straightforward again to graph this by going to insert. Let's see if this works for me. Nope. Once again, I have to just grab the content of the table and make the graph, and then we'll have to go in and add what is it doing? I have trouble with Excel when in this case, both the column headers and the row headers are numbers, and I'm thinking that it thinks that those are data, and I don't know what the problem is. That's what I'm struggling with right now. But maybe it's just me. Let's see what happens if I label these. And then retry to do that. There we go. Alrighty. And then if we can just right-click, select data, go in and edit the series names, then we're cooking. Now everything's working again. And so on. You get the point. And so there we go. We can look and see, again, how many records were submitted in the different months and in the different years. And right now, it's summarized with month across the x-axis and year as the content. If you would like to switch that, you can right-click in there and click again on the select data. And if you do this switch row column, what that will do is switch that around for you now, where we've got, this would be 2011, 2012, 2013, 2014, and 2015, with the different months appearing as the different colors. And you can also, of course, change how that's displayed. If you wanted to just change the type of graph, it might be easier to look at, say, the column graph in there. And what will jump out at you pretty quickly is that you've got a seasonal oscillation. We definitely are picking up peaks in the spring and then in the fall, and definitely very apparent in the different years that we've got represented in this data sheet here. And that's reflective of course, whenever people like to go out and collect data. Generally, kind of programmatically in Nature's Notebook, we have the most observations submitted in the spring months, the second most submitted in the fall months, the third most in the summer, and then we kind of drop off a bit in the winter time, which is, you know, totally understandable. In much of the country, not much is happening in the winter. Are there any questions along specific to what I did there, other than what I did with the graph? That might have been kind of confusing. Okay, Well, if you're still thinking about that, I'm going to go ahead and label this sheet. We're going to say observations by, let's see, this was record by month, year. We can reference that if we want to. We're going to save. And I'm going to go delete, again, my intermediate working pivot table, just because it's going to get messy here pretty quick otherwise. And then we can go back to what our last question was regarding summary statistics. For this last one, it's going to get a little more exciting. For this one, our question was on how many unique dates did each of my participants take observations? And so in this case, what we're trying to total up is how many dates did each person make observations? Now, if we go back to our original spreadsheet, that seems fairly straightforward. However, if you created the pivot table directly from this table right now, you would get a gross overestimation of the unique dates, because recall, for each date, you have a whole boatload of different observations by observer, because, actually I'm not illustrating that well here, but recall, every time that you go out and make an observation on a single individual, you're most likely submitting several records. And so what we want to do is condense that down such that we only have a single observation or single record in our table for each time a person went out. So there's a ton of redundancy right here that we're going to have to clean out before we can summarize that. So the best way, the way that I like to handle that is to simply copy the entire spreadsheet to a new sheet, copy and paste, and then what we're going to do is take out, again, the columns that are not relevant to this particular analysis. In this case, we only care about the date and the observer. We do not at all care about the phenophase at this point. That is not part of the story. So we're going to get rid of all of that, all of those fields. And we actually don't really care about the partner group either. We care about the observed by person ID and the date. And that's it, pretty much. And that's, oh, phenophase status, we also don't need that either. And so now what we're going to do, we've cleaned out everything else, but we still have a ton of redundancy. We still have all of the records. We just got rid of some of the fields. And so to clean out that redundancy, we can use this really cool feature in Excel called Remove Duplicates. And I know it's under the Data menu on a PC. I'm pretty sure it's under the Data menu on a Mac also. And you go to Data, and you're looking for something called Remove Duplicates. And basically what it does is pretty much what this cute little picture shows. What the scenario was there is that there were 3 blue records and 2 yellows, and we only wanted 1 of each. And so it deletes all of those redundant records. And that's exactly what we're going to do in this case, so that we are trimmed down to just 1 record per person per date. And so we go to Remove Duplicates. And what it's going to do here is ask you which fields do you want to consider your duplicates on. And in this case, we could leave them all checked because a number of these are redundant anyways, or you could be very specific. You can say uncheck all, and you would say, well, by person and by date, and say OK, and then it's going to just go ahead and automatically crunch that file down for you. And so you'll see that we took 62,659 records out. Those were all duplicates, and those were found and removed, and we're left with only 2,100 records in this file now. It used to be 65,000 or close to that. And so now, does that make sense so far? Let me know if I lost anybody. What we have now is simply a much, much reduced file that just has a single record per person per date, and that's what we'll create our pivot table on. So now we simply, let's see, select the whole spreadsheet. Again, go to Insert, Pivot Table, go with the defaults here again, and then we'll say by person and by observation date. And again, we can do a count on anything here. As long as we count, we want count. Wait a second. Nope, that's not right. Observer in year. Sorry about that. That's not right. Year. There we go. That looks a lot better. Now what we have is how many unique dates did each observer go out on and observe in each year. And so once again, if we want to, we can select that spreadsheet. And we're just going to get a section of this because we don't need the whole thing. Copy and paste that into a new worksheet. And we don't need the blank one. And there you go. And again, if you want to graph that in any way, you can, however you want to visualize it or total it up. But that is the answer for how many different unique days in each year the observers observed on. We should say dates by observer year. And I'll save that. And I will delete my intermediate spreadsheets. I'm definitely, let's see, this one was the one where we reduced our file. So maybe I will keep that so that I can go backtrack on my work if I need to in the future. This is my, I would call this spreadsheet, unique, let's see, observer dates. And then my working spreadsheet we'll get rid of. Our pivot table, we don't need that either. Okay, are there any questions along that, regarding any of that? All right, if not, then I'm planning to move on to participant retention and a little bit, just show you a little bit on how I have come up with ways to track how many people we are keeping active in Nature's Notebook from one year to the next. It's definitely something that we care about a lot because there's such an investment in training people, and I'm sure you guys can completely relate to this. You spend an enormous amount of time actually getting people set up with your program and educated on what the phenophase descriptions are and identifying where those plants are that you want them to observe and basically learning the ropes. Once you've invested all that time, you would really like to keep them. And you would really like to know how good you are at keeping them. And so I've come up with some ways that it's not too terrible to track. And so the kinds of questions that you're probably likely to be interested in when you're thinking about observer retention is what is that year-to-year observer retention rate? And then relatedly, which may not make a lot of sense right off the bat, what is my long-term observer retention rate? And how can I plot this? I will show you, and it might make more sense when you see this, what I mean by that. But basically, I've come up with two different ways of thinking about retention, and it kind of depends on what your question is, what your application is, which one is a better metric to use. What you can think about is whatever group of people that you train in any particular, and I generally think about this in terms of years. You might break it down into different time frames, but a year seems like a fairly logical unit of time to work with. If you had a group of people start in 2011, then that would be what I call your 2011 cohort. And what proportion of those people remain active going into 2012 or 2013 or 2014 or 2015? And that's what I'm calling the long-term observer retention rate, that number 2 metric. Another way to look at that, and so basically when you're looking at that long-term retention rate, typically what you see is it'll start at obviously 100% in the first year. You treat everything in the first year as 100%, and that 100% represents anybody that started and actually submitted data in that first year. And then in subsequent years, it's going to trail off, probably, hopefully, not too terribly, but usually drop off rather precipitously into the second year, and then hopefully kind of level out going into subsequent years after that. The year-to-year observer retention rate is a slightly different way of looking at things by saying, all right, so we had a group of people start in 2011, then what proportion of them sustained activity into 2012? And for us, it's usually somewhere around 20 to 30% of people that collected data in the first year that go on to collect data in that second year. But then of those, that number of people, how many of those sustained activity going into 2013? And so you, rather than looking back to the 2011 numbers, you just say, well, what proportion then of the people that were active in 2012 sustained activity in 2013? And so each year is just a function of the previous year. And again, this may make more sense when I show it to you. But what we find is that for our numbers, for Nature's Notebook overall, once you get folks going into that second year, then the fraction of them that remain active in subsequent years is usually upwards of more like 80 to 90%. And so that's kind of a really handy number to be able to communicate as well. But it's a different number because in each year you're just referencing the previous number, amount of people that were active, rather than referencing the size of the initial cohort. And so, again, maybe that'll make sense when I show it to you. And then I'll show you how different ways you can plot this. So, going back to our original spreadsheet, and again, I probably should have titled this something more logical, like original data, because this is the spreadsheet that I keep going back to over and over again. This is the original unfettered with data. What is my year-to-year retention rate? So let's figure that out. And so in this case, again, we don't care so much about actually we don't care so much at all about we definitely don't care about the phenofaces that people observed. We don't even care about how many records they submitted. We don't actually even care about what dates they submitted on. We simply are caring, were they active at all in a given year? So really all we need to boil this spreadsheet down to is observer and year. And so I'm going to copy this again. We're going to do the same thing that we did in the previous example where we paste it again. We're going to remove duplicates now based on the observed by person ID, or the observer ID, and the year, and get rid of everything else. So it's going to dramatically shrink this file again. So I have it highlighted, and again, I'm going to go to that data remove duplicates function, and it defaults to selecting everything. We unselect them all, and then we're going to select the person, and the year, because that's all we care about is if a person was active in any year, and say OK, and then it dumped almost everything. We're left with 291 unique values. Now, since we removed all those duplicates based on everything but observer and year, it really doesn't make sense to keep any of these fields anymore because that would be very misleading. And so I'm going to delete all of those too. And I better name this worksheet so I know what I'm doing. And this is spreadsheet unique observer year. So that I know what I'm doing. And then we're going to simply summarize by observer and year. And so we highlight those two columns, insert a pivot table, and go with the defaults again. And we'll say observed by person ID in the rows, the year in the columns, year, pull that down again into the values. And now what that is a binary, because either people observed in a given year or they did not. And so if they did, it shows up as a 1, and if they did not, it's a blank. And so we can copy that. And I'm not going to get it all. I'm going to get a chunk again just to work with because there's a lot of people in this particular network. Add a spreadsheet, paste them here. And then what we can do to make this make a lot more sense, basically what to orient you, what we're looking at again here is for each person, which is a unique row again, what years did they submit data in or not? And so recall again, number 5, user number 5 is Jake, our executive director. And we remember from the very, very first thing that we summarized, we know he did submit data in 2011, 2012, not in 2013, in 2014, and not yet in 2015, though I'm sure he will. But it would be very interesting to know what other people maybe followed that same pattern of activity, or what people, who else started in that 2011, in that year of 2011, or it would be called our 2011 cohort here, meaning that they first submitted data in that year. And so the easiest way I have found to summarize this in a way that makes sense logically to me is to highlight the whole thing and then sort it by year. And so highlight that and data sort. And on a Mac, I'm not entirely sure if the sort is under the data, but I thought I remembered that it is. But you're looking for the sort function, and you're simply going to just add the years in chronological order here, all 5 years. And I think previous versions of Excel don't let you do more than 3, so you'll have to do it, you'll have to sort by the first 3 and then the next ones, but that should work. And what that does now is makes it very clear. Let's see, I'll bold this. I like to bold my top rows just to make things easier to see. And then also I'm going to freeze the top row by view freeze panes, because that way it's easy to see too what's going on as we scroll down. But it makes it very easy to see who was in this 2011 cohort. It's this group of people. And then you'll see that the next batch down did not submit any data in 2011. They are my 2012 cohort. And then if we keep on scrolling down, we then see our 2013 cohort, and so on. And the other thing that's handy about sorting it in this way is you can see pretty quickly, all right, so of my 2011 cohort, which proportion of them remained active in 2012, and then which proportion of those guys remained active in 2013. And so you can visually see it very quickly, and it's also pretty easy to summarize too. The summarization part is a little more tedious, and I'll show you what I have done. I don't know if this is the best way, but it is a way of tracking this sort of thing. One thing I like to do just for fun is to highlight the cohort just so that I can kind of keep track of where a cohort stops and starts, because that's kind of what we're referencing. And so what I do next, I guess maybe I should ask, I'll pause for a moment if there are any questions on how I got to this point so far. Okay, if not, then what I tend to like to do, which seems fairly logical to me, show sorting. Yes, I can definitely show sorting again. Sure. How I did that was I selected the entire sheet, and if you're on a PC, it's data sort, and then I had to add a level. I had to add a level for each of the years. And I just went with the defaults, which are smallest to largest. It doesn't really matter in this case. Well, I guess it does, because that's basically the ones versus the zeros. So yes, it does matter. And then okay, and that's how we arrived at that kind of step-looking summary. So then, how I like to think about this then is to think about the different cohorts in terms of, again, you're going to calculate how they sustained from one year to the next. And so what I generally do is I'll make a little summary table over here. We're going to say I just title it my cohort. We've got our 2011 cohort, our 2012 cohort, 2013, 2014, and I don't think I have any 2015 because I didn't grab that far down in the table. And then what we're going to do is say, okay, how many of those did we start in year 1? How many sustained activity in year 2? How many sustained activity in year 3, year 4, and so on. And so this is the kind of slow part of things. What we have to do to establish our baseline values for what happened in year 1 is basically just go count these guys. And so I highlight my whole entire cohort for 2011, and then if you look down in the lower right, you can look at the count here. Hopefully your Excel has this as a default. I can't remember if that's a default setting or not. I think it is. Then we know that we had 12 people start in 2011, and so that's going to be what comprises this number here. Then we do the same thing for our 2012 cohort. How many people started in what we call year 1 there? That's 24. We go pop a 24 in here. How many people started in a 2013 cohort? We have 76. And then lastly, how many did we grab that we're calling our 2014 cohort? Lots. Okay, that was a good year. 123. Okay. Whoops. Now we want to know, okay, what proportion of them remained active from one year to the next? Well, the first thing we've got to do is just do the same counting thing. So how many people were active from our 2011 cohort in year 2? And in this case, it is 5. And then, whoops, what happened there? Sorry. How many remained active in year 3? It was 4. And then year 4, it was 5. And this is where things get a little interesting, because you'll see that we dropped somebody, but we picked someone else back up. And so depending on how you want to count that, it's up to you to kind of make the decision. And I'll add a year 5 here. We have one person there. Those are all just definitely decisions that you can make based on how you want to track these kinds of things. And then we do the same thing to fill out the rest. How many people were sustained activity in year 2 of our 2012 cohort? That's these 4 people. And then into year 3, we have 3. And then year 4 is 2. And you'll notice pretty quickly, too, we end up with a triangular matrix in this summary table because these folks started a year later than these folks. And so they don't have the opportunity to have their year 5 data yet. And as we get down into the 2013 folks, they aren't going to have the chance to have a year 4 or a year 5. So I'll just do those real quick so you can see what that looks like. That's going to be 6 and 1. And then I guess we can go see how many 2014 people too. So that 2. That's going to be terrible. 2 out of 123 is not good. Alrighty, and so now those are the counts. And so now what you can do is summarize those in either of the 2 ways that I described when I was showing you the PowerPoint slide. What I like to do is copy the whole table because it's formatted already nice and neatly. And then what we are doing here is if we're going to do first the long term, then the long term is again where you're keeping track of what proportion of that initial year's number of people remains active long term. And I'm going to do this one first because I think it makes a little bit more logical sense. And what you can do is create a formula that you can click and drag down pretty easily. Let me think. This is too hard. If we're going to do it as a percent, in every year, it's 100% in every cohort, it's 100% in the first year. And then we want to be able to say, okay, what does it drop to in subsequent years? And so in this case, what you're going to do is say 5 is a fraction of 12. If we type in the 12 here, then we can drag it over times 100. And then we pull that over. And so basically what we're saying is, what was our long-term retention among the folks that started in 2011? Well, 42% of them remained active in the second year. 33% of that cohort remained active in year 3. We jumped back up to 42 in year 4, and then it dropped down to 8 in year 5. To calculate that for the next year, again, how I did that was, let's see, I referenced this cell, and then I'm saying the denominator is 24, and we're going to have the denominator be 24 the whole way through. So I'll just type that in, times 100, so that it's a percent. Drag it over. You can do that again here, and that's going to be reference this cell with the 6 in it, and the denominator, again, is the 76 that started in 2013 times 100. Drag that over, whoops, just to the 1 cell. And then finally, this one's going to be painfully small, the 2 over 123 times 100. And then if we don't want all these messy decimal places, we can hit right-click and say Format Cells, tell it it's a number, and then say 1 or 0, just so that it's a little neater to look at. And then one thing that I kind of like to do, I kind of think it's neat to look at this as a line graph sometimes. You can say Insert, Line Graph, and then something's wrong here because I know why it's using the year again. Don't use the year as part of the data. There we go. So what we see here, and this is completely, if it makes sense to you, to visualize it this way, is everybody starts at 100. So you can set your axis maximum at 100, and then you can look to see what kind of drop-off rates you have. And what this enables you to do is compare from one cohort to the next, and of course they need to be labeled because my graph is giving me grief. Series 1 is 2011. Series 2 is our 2012 cohort. Maybe you can even call it that if you want. Series 3 is our folks that started in 2013. And Series 4 is our folks that started in 2014. Then you can just kind of look at the slopes of those lines and how they carry out over time. And this isn't the most realistic situation because remember I didn't grab the entire data file. This is just a little test case. But definitely if this were our real data, I would be kind of sad because basically we're having lower and lower retention of our people among each subsequent cohort. So we did the best at retaining people that started in 2011 and the worst at retaining people that started in 2014. And so that would definitely be a red flag to me that we are doing something terribly wrong here and look back at what did we do in 2012 or 2011 because that seems to be the best situation. Okay, are there any questions about that? I know that can be kind of confusing. I'll leave that there. And then what I'll do is, for comparison's sake, show you how I calculate the other kind of retention. Because again, it can also be kind of insightful too to see that basically what this tells you is how much drop-off do we have right off the bat and how well do we do carrying it forward for the people that started in a particular year. The other kind of retention tells you, okay, how many people did we drop right off the bat? But then of those that we keep, how well did we do at keeping them year after year? And so it kind of puts the focus more on how well do we do at keeping the ones that we're really actually interested in keeping. And so what I'll do again is copy and paste that same table so that we have our formatting retained. This is the year to year retention. I will delete these values here. And so instead of, we calculate things basically the same way where we're referencing each year, but instead of referencing it back every year back to the beginning of the cohort, the year 1, we're going to reference it to the previous year. And so what we're going to do, I hope that makes sense, is again, you know what, I need to make sure that these are calculated as 100 also, so we're just going to say 100, 100, because again, you treat each thing as that's where we started, and then what happens after that, what we're going to do is say, okay, this guy compared to this previous year, and of course multiply it by 100, but then instead of, for this year, having it be this year compared to 12, the year 1 is going to be compared to year 2. So we just kind of reference the previous year times 100. And I'll do this longhand this way, cell by cell, but you can accomplish the same thing by just by copying to the right also, which I'll show you in the next one. So here we're saying this compared to this, which you'll notice real quickly gets up over 100% here, which is interesting. And then finally, year 5, over year 4 times 100 brings you back down to 20. We can accomplish the exact same thing here by saying 4 divided by 24 times 100. And then if you just drag that to the right, that actually does the same thing. If you peek in there, you'll see that this one is, J over K, is that right? Did I get that backwards? No, that's right. Okay. K over J, sorry. And then this one should be L over K, and it is. Okay. We can do the same thing by dragging this down and dragging this over. And then, because I don't love all those decimal places in there because it's just hard to see, I'm going to go in here and say no thanks about the decimal places. I'm going to save it really quick. And then again, we can plot this in a nice line graph to see if it tells us anything interesting. And it does. It tells us something very different than the previous graph. Again, I'm going to go in, I'm going to name my series real quick. This is my 2011 cohort. This one's my 2012. This one's 2013. And the last one's my group of folks that started in 2014. And what we can do here now is see, okay, oh, and this should be, actually, this can remain greater than 100% because, as you see over here, it is possible for it to jump up over 100%. And where that comes from is that if you re-engage people that had appeared to have dropped off, that were active in 1 year, dropped off in the next year, but then you pick them back up in subsequent years. And so that can result in retention rates that are greater than 100%. And so what that tells you is if 100% is our baseline, then going in from 1 year to year 2, we drop down precipitously, which always happens for us anyways, to as high as 40%, but as low as, what is that, 2%. But then of those people, and this is really the very important breakpoint that I have observed for sure among all Nature's Notebook participants, is that if you get them active in year 2, if you can get them into year 3, then things generally stay much higher after that. Again, this data file isn't entirely representative of our situation because I didn't use the whole thing. This is just a kind of fake subset of the data. But even if we look at our 2011 cohort, we had it drop way down in year 2, but then it climbed back up into year 3 and even year 4. It's also a bit maybe stretching things to into an overinterpretation because recall that we're working with numbers of 5 and 4 people and 1 person. So when you convert that to a percent, they're all normalized. You know, we're losing track of the fact that 2011 has such smaller numbers of people. But if you want to be able to compare year to year, which is apples to apples basically, then this is one way you can do that. And we do indeed see that pattern bear out, except for this in year 5 where it's dropped. But we're not going to worry about that because 2015 isn't done yet. And so it never really makes sense to summarize the data for a year that isn't done yet because the story can change dramatically even after past the midpoint of the year. So are there any questions on any of that or any thoughts as to how you might use this kind of summary, if it's useful to you at all or if it's just super confusing? Okay, well, hopefully that at least engenders some thinking about that kind of thing. And if any of you have any thoughts too as to how you like to calculate this kind of thing, or if there are other metrics that you use that you think are more meaningful, I would love to hear about them. This is basically just stuff I've sort of come up with by just messing with our data to try and figure out what's going on and what can explain different patterns and to try and engender the highest retention rates as possible, or to understand is there anything that we do that has any influence over that, or is it just so many factors that we have no control over? But I'm certainly open to hearing other thoughts on this too. So I'm going to go ahead and rename this my retention sheet. I'm going to dump my pivot table sheet because, as you can see, it's getting pretty full here. Save my file. And if there aren't any other comments or questions, that concludes the participant retention portion of our webinar. And we're going to move on to observer accuracy, because this is a question that we get fairly regularly too. Basically, many group leaders are curious to know, how can I know how well do my volunteers' reports match mine if I'm the expert? And how can I identify, is there any quick way to identify whether anybody is submitting observations that seem way out of range without me having to go in there, manually look at the observation deck or page through their spreadsheets or data sheets that they're submitting. And so I played around with this a little bit, and I did come up with one. It's kind of tedious, but one way of doing this. The reason why it's tedious is that you have to compare, you have to do this analysis for every phenophase. You can only do this analysis for one phenophase for one individual plant or animal at a time. And I constrain it to a year too. Yeah, actually, yes, you do have to constrain it to the year as well. So for each individual, for each phenophase, for each year. So if you have, say, 5 species that you're tracking in multiple years and you care about more than the phenophases, you can pretty quickly see that this isn't the most efficient thing to do, but it is a way to look at whether there are outliers. And since I will just kind of share with you too, since we've heard this concern from multiple fronts now, it hasn't been a way that we have thought about offering the data through a visualization tool, through anything automated just yet, but it's certainly something that we're now thinking about. And so there aren't at the present, any plans to develop tools that automate this kind of process, but it's something that we will definitely be keeping in mind as we determine what our next tool development plans look like. Okay, so going back to our original data, if we were going to drill down now again on an individual plant and a single phase and a single year, so what we're going to do to start off is to copy this whole spreadsheet to a new one so that we can work with it again, because we're going to have to dump a whole lot of records. And then what we can do is get rid of these columns that we don't need, like partner groups, goodbye. What we do need is the individual ID, because that references our individual plant. We don't really need the common name because that's redundant with whatever the individual is, but I'll leave it on there for now. We definitely need the phenophase so that we know which one we're looking at there. So I'll highlight that one too. The phenophase ID is redundant. You'll see that's the code for what the phenophase description is. So I'm going to get rid of that because it's redundant. We definitely need the day of year because that's what we're going to look at. And we're going to limit things by year. So we'll definitely retain year. We definitely want phenophase status because that's what we're really looking at evaluating in this case. Did people say yes when you said no? Did people say no when you said yes? And were those reports way out of range in reference to the day of year? And so what we're going to do is pay attention to those things and narrow this down. And so an easy way to narrow down what we're going to look at is by using the filter function. And so again, on a PC, it's on the data menu. I'm not positive on a Mac where the filtering is. So we can look into that if you need assistance with that. I think it was Suzanne after the fact. But if you hit the filter, then it will add these nifty little drop downs to each of your fields, each of your columns, and then you can limit what records you're looking at based on that. And so, for example, we might say we are interested in looking at, oh my goodness, let me limit this first. Okay, we're gonna focus on, we're gonna select none. We're gonna pick a creosote bush. I know we have data for creosote bush. And then we're going to select just this first individual. So I'm going to unselect everybody, just pick this guy. And then why don't we look at the records for flowers? So I'm going to unselect everybody, select flowers here. And then we're going to limit ourselves to 2012. I hope this has good data. And so now, oh, no, that's not going to work. That's probably not enough records. We want to be able to have something to compare. Okay, maybe 2012 will work. 2012. 2013. I apologize for not. Okay. Okay. All right, so what we're going to do is pretend like the observer number 3598 is our, actually, let me sort by this real quick. I'm basically going to figure out who has reasonable data to pretend is our expert. All right. Okay, we're going to pretend like 18581 is our expert because that person has some interesting records, it looks like. Yes, that person is our expert. Okay. All right. So what you're going to want to do is move, let's see. First thing I'm going to do is copy just this because we've filtered. The interesting thing about the filtering is that it only shows you certain records, but the all of the records are still in this worksheet, but if we copy a subset that we've filtered then and paste them, it will only give us those filtered records. And so that, again, that's what we want to work from, because we don't want to have extra data in there that we didn't need. You'll see that we've got just the creosote in just 2013 that we chose. I'm going to cut these ones out and move them to the top, because this is our so-called expert, and I hope there is some agreement or lack of agreement with the others. And so now what we're going to do is make scatter plots for the day, based on the day of year and the phenophase status, and we're going to make individual ones for this expert's reports and then for everyone else's reports, and then just visually compare them. And so what we need to do is have the day of year and the phenophase status, and then I'm going to put the observer over here too. And then use these as the scatter plot. Or the reason why I put the observer over here is so that it's easy for me to be able to see which records I'm going to plot. So for the first scatter plot, where I'm doing it for the experts, I need the information for the phenophase status, which is the yes or the no again, as well as the day of year. And then we're going to select those and then insert a scatter plot, which is this like polka dot looking graph. And what that does now is create for you the day of year is along the x-axis for this particular year. This is just the 2013 data. And then you have points that are either plotting as a 0, which would be a no, or a 1, which is a yes. Excel isn't smart enough to know that these are only binary. If you want to, though, it kind of makes sense to go in there and tell it that the major units are 1 and tell it to only go from 1 to 0. And that way, you don't have that confusing stuff in there. And then the other thing you can do is even change the y-axis, because you'll see that it auto fit to just the portion of days of year where we had data, but that should be your whole year. And so we could say day 1 to 365. Actually, if we make it 0, then they plot more nicely in terms of the labels. And so there you can see this is where you're expert. So we're going to title this one Expert Reports for Creosote, creosote flowers in 2013. So again, that's pretty darn specific, but that's your expert. And now let's plot the everyone else's reports and see how those match up. And so what we're going to do now is just select, again, the day of year and the phenophase status for everybody else. And so everybody else are the data that are not highlighted in yellow. And so we grab these two and go down to the bottom here. And then we'll, again, insert our scatter plot, which is our polka dot graph. And then we're going to move this up so that it's right underneath the other one. If that's possible, Excel. And then we're going to make it look like the other one, too. We want to make sure that, okay, we've got a -1, so there was a I don't know record. Again, if we change our axis here, we want to make sure for sure that our x-axis matches. Format axis. Okay, we're going to say max 365 and minimum 0, and that is important because that way now they should match up. No, it did not. 0 and 365. And then if we mess with our y-axis, we can just kind of get rid of those extra tick marks and say minimum -1, maximum 1, major units 1. And then that'll make it look a little bit neater. And so there now, if I crunch these both so that we can view them both on the same chart at the same screen at the same time, and the trick is to make them the same length. And then this is volunteer reports for creosote flowers in 2013. Now you're comparing apples to apples. And what we noticed pretty quickly is the expert reported yes to flowers only here, up here in that range of data or dates, and no to here, to all these other dates. or this person that we called our expert, and everybody else had a much wider range of yeses for the flowers, overlapping with a range of no's for the flowers, and then also an I don't know. And so that's kind of an interesting pattern to notice, that we've definitely got some disagreement going on here. And then one other thing is you have a bit of an outlier. It appears to be an outlier, but what it is simply somebody reported a record way back on day 43 and nobody else did. And your expert doesn't have any data for that date either. And so that isn't necessarily wrong. It's just a time of year when no one else looked. But rather, these periods of not being in agreement with the expert might be something that you would want to pay more attention to. And so that's basically what you can do. Like I said, it's kind of a long-handed, tedious way of teasing apart whether you've got good agreement or not. And if you were interested in figuring out who these people were that reported things that you weren't sure of, if you roll over the points, it will tell you what day of year, and then you can go back down in your data table and figure out who that was also. Are there any questions or comments specific to that? Okay, so I'm going to save that one then. Save that data sheet as accuracy, and I will get rid of my working spreadsheet in here because that was really intermediate and messy. And the last thing that I thought I would walk you through is some of the neat stuff that the visualization tool will allow you to do. It's actually going to be a much more powerful iteration of the tool. I don't know if any of you were around or used the previous version of our Viz tool. That died about 6 or 8 months ago, more like 6 months ago. What ended up happening was it had been built utilizing an API, a Google API that Google sundowned, and we didn't have the way to repurpose the tool to reference something else, and so we had to kind of start from scratch. But that was kind of a blessing in disguise because the new tool does almost everything that the last one does, plus a whole lot more interesting things, in my opinion. This new Viz tool will allow you to not only visualize your data in a calendar sort of format, but it has more flexibility than the last one did, and I'll show you what I mean by that. As well as, this is the new part, relationships between your phenology reports and abionic variables, things like latitude and longitude and elevation and seasonal precipitation totals and seasonal temperature summaries, and even day length, which is really pretty cool. And then finally, of course, spatial patterns. You can visualize things using a map interface. It's also got some cool enhancements where you can select the data or visualize it by things like park boundaries or Fish and Wildlife Service regions, some of the things that some of our partners really expressed interest in. And of course, you can select and summarize the data by partner group, which our last tool did not allow you to do, and I'm so glad that we have. And so I'm just going to give you a brief sneak preview, and I definitely encourage you to consider joining the webinar that we're going to offer on this on July 14th, where the developers who created this will walk you through in much greater detail the great things that you can do with it and the most efficient ways to do that. And so you can check that out on our webinar page. And that's scheduled for mid-July because we didn't want to have it, we wanted to make sure that we released the tool and gave it some time to get the bugs worked out. We're pretty confident that it's going to work well, and we're in the final phases of testing that right now and seeing if we can make it crash. But we're giving ourselves just a little bit of a window. But as soon as it is deployed on our live website, we will be sure to let you all know so that you can begin to play with it yourself and explore your data live. In the meantime, we have to access the version that's on our developer site, so it's not perfect. The address is www-dev. Thank you. There we go. Okay. Okay. So it starts out looking something like this, where it will load a map for you. And what I'm going to do is show you, let's see, some stuff for the Northeast, because that is a region where I know we have lots of data. And again, since this is our dev site, it's not connected to the live website, and so it doesn't have this year's data. Actually, I went too far in. And I'm not super great with this either, since it's brand new. But I just want to kind of show you some of the things that I know we can do. So the very first thing that you want to do is select what period of time you're interested in thinking about, and we'll go 2013 and 2014 because I know 2015 is not in here. And then we add that to the map. And if we take, for example, some maples, we can pretty quickly plot our, whoops, what happened? You can see where we've got maple data in those years. And again, don't freak out if this doesn't, if you think, oh, we have data, but my site's not showing up, and I know we have data. That's probably because this database isn't synced accurately with our live database. It's just a working database. And then if we select a region, we can, and I'm not really trying to do anything sensical here other than show you. I'm picking a bunch of sites here quickly so that we can go to the cool tools, which is hidden under here. And this is where you can get at either the calendar or the scatter plot. The calendar is going to look, if you used our previous visualization tool, it's going to look kind of familiar to you. What you can do, again, is using the data that we just selected, we can say pick a year or two. And then let's pick a couple of phenophases. Let's say full flowering. We'll say, do we have any full flowering data for red maples in that region in 2013 and 2014? And visualize, and no, that didn't give me anything. Uh-oh. Shoot, what am I doing wrong? Okay, phew. Again, I think it's a function of the database just not being synced with the real thing. The point is, what we're looking at here is in this pretend data world. For the Northeast, the region of the country that I grabbed a box around, so for all the sites that fall within that hypothetical region, when did people report yeses to seeing leaves on red maples in 2013, as well as when did they report yes to leaves on red maples in 2014? And so across that region, that does allow you to see that in general, the period for which leaves were reported for red maples was really pretty consistent from one year to the next, with the exception of a couple of outliers here. Which then, so that alone is pretty neat that you can summarize that. But then it certainly begs that question as to, well, do we have these outliers here because that's when it started? And is that when it really started in 2014 also, or were there just no records reported yeses or nos, or did we actually have a bunch of nos here that would help us understand that these were indeed early in 2013 and not in 2014? So a neat feature that you can do is go up here and click the negative data button and add that then as gray bars. And so now what you see is every time it's shaded green, that means somebody in that region reported a yes to leaves for red maples. And every time that you have a gray line, that means that somebody reported no to leaves in red maples. And I guess I should specify too that the yeses override the no's. So when you're summarizing across many sites, if anybody said yes, then it'll show up as a green here. However, if you see gray, that means everybody said no. And so what's interesting, the answer to our question is no, it wasn't that there were earlier reports for leaves in red maples in 2014 and that nobody reported them. Lots of people seem to have reported no's and nobody reported yeses, whereas in 2013 you did have a couple of yeses as well as a bunch of no's too. So that's an interesting thing to explore. And then the other, so there's lots more about that the folks that do the webinar will walk you through, but I just kind of wanted to demonstrate that. The beautiful thing is you can get to this in Excel in a much, much more long-handed way using the data file that I was that we were just working with in the rest of the webinar. It's entirely possible to summarize things and produce graphs that look pretty similar to this. But I'm not going to bother showing you all that because you'll be able to use this tool so much more quickly and easily going forward. And so it just makes sense to do it this way. And then the other really cool thing that we can do now that we never have been able to do before is these things called scatter plots, which again, we're going to summarize data for red maple in this region that I have selected as a box, and then go here to a scatter plot. And what we can do is say, okay, let's look at those leaves data again for red maple. And then let's compare that, the timing of when leaves were reported in red maple, to one of these other abiotic variables. So is there a pattern with when we first report yeses? And this is based on when we first report yeses at the different sites. Is there any sort of relationship with that to, say, latitude? I don't know. Let's find out. Let's plot those data, and there they are. Those are all the first reports of yeses for leaves and red maples across all those sites in 2013 and 2014 against latitude. So latitude is the x-axis. So you've got your lowest latitudes or your furthest south on the left, and then going north as you go up, go to the right on your x-axis. And then the onset day reported in day of year, that's what DOY stands for, here. And so in some cases we might expect that we would have earlier leaf out at lower latitudes because generally it tends to warm up sooner in the year at lower latitudes than it does at high latitudes. And so definitely there is some sort of pattern here, but the really cool thing is that we can then go hit fit line to see if there is any sort of relationship. And based on the data that we have here, there is definitely no relationship. There is a R-square of 0. But what's really cool is that it's very quick to say, oh, okay, well, that didn't matter. Is there another variable that seems to matter? What about spring precipitation? Does that seem to make a difference? How do I get it to reload? There we go. And then we can, oops, let me get rid of that one. Visualize that and put a line there and see if there's, whoops, any sort of relationship with precipitation. Well, a tiny bit more, but still not a great fit. And we can mess with things like day length, which means how long is the day. It actually does look like there's a pretty clear relationship there, but we've got a couple of outliers here that are totally throwing off the relationship. So the trade-off here is that you can't exclude those outliers easily. You probably have to go back to figure out which sites they were in and exclude those from your selection box, or download these data and actually take it into a statistics package and begin to play with it for real. But this does allow you to begin to just kind of get a sense for, well, are there variables that seem like they are explaining some of the stuff that we're seeing or not? So interestingly enough, leaves in red maples probably are impacted quite a bit by day length. And we can do the same for any other region of the country or suite of phenophases or species that are of interest too. Let's see, so I told you about the webinar. I think that was all that I had planned on covering. So I am definitely open to hearing if you have any questions on any of those things, or would like further explanation or demonstration of anything in particular that we talked about here. If you have any additional questions, you're welcome to ask those now or in follow-up emails or whatever is helpful to you. And like we said too, we're recording this, so I know it's an awful lot to take in all at once. And so I definitely got feedback from some of the participants in the previous webinar that it was hard to keep up and easier to just sit back and watch, but that they were referencing the recording as they settled down to actually try to calculate some of these things using their own data. So if you find that that's helpful, that's great. And also too, if you have thoughts as to an even more useful format for conveying this information I'm open to hearing that too. We basically just really want to make sure that you're able to get your pressing questions answered, because if you can't, then what would be your motivation to keep on working with this program? And so we just really want to try to break down as many of those barriers as we can. Okay, well, if there aren't any other thoughts or questions, then I don't want to tie up any more of your time today, but I definitely encourage you to let me know, ask away or share whatever your feelings and thoughts are. And definitely, please keep in touch as other needs arise. We'll certainly try to meet those as best as we can. All right, well, thank you all so much for joining today. It was really nice to work with you. I hope it's helpful. Take care. Bye.